All right, this is the second part of lesson 10.2. So now we're going to look at systems of inequalities. But we're going to start with a review of systems of, we're actually going to look at, are these solutions to equations? Now, this is going to fit into the last section. When we have this line drawn, sometimes they'll ask, is a certain point a solution? So I've actually given three here. I put one inside the shaded region, one outside the shaded region, and then one exactly on the line so we can actually see what happens. So anything that's in, so if you're given a coordinate, basically type it in, have a look, see where it is on the picture. So anything that's inside the shaded region, that is going to be a solution to this question. So 2, 3, that one's good. The 3, 2 here, however, and I'm just switching it on and off so you can just see. And notice that's outside the region, so that would be no. And this one's a little more complicated. When it's on the line, do we count it? Now, it actually depends on this part. It depends on the inequality itself. Notice this doesn't have an equal sign on it. Therefore, as it's exactly on the line, that means that we cannot include it for this question. If this had an equal sign underneath it, then the point line on the line would be equal to the line, and we would accept it. So when we don't see the equal sign, if it lies on the line, we do not count it. If there is an equal sign, then we would count it. So I think I can actually change this to greater than or equal to. So now, if it's a solid line, if it lies on the solid line, then absolutely, this would therefore be a solution to this question. And actually, you can see exactly that same thing here, where I actually did put the equal sign just so you can see the difference. So dotted line, we do not count the line, but solid line, we do count the line. And I just put one more up here for us. So y is less than negative 1/2 x plus 3. Which of these would be solutions? So first of all, you type it in so you can see where the shaded region is. And then you would just type in each coordinate. So 1, 3, I can see is outside. So that will be a no. 3, 1. Oops, I didn't mean to type in both together. 3, 1, you can see is inside the shaded region. So that would be a solution. 4, 1. Dotted line, and it lies on the dotted line, so we do not count the dotted line, so that would be a no as well. And the last one, 5, 0. And 5, 0, you can see is also in the shaded region. So these would be the two that would count for that type of question. Now, that's going to help us as we move on to systems. So first of all, just review what a system of equations is with the equal sign. That's going to be two lines that's graphed, and you actually look where they cross. So 2, 5 is the intersection. So that means x equals 2 and y equals 5 is the solution to that problem. Now, as we move on, there's a couple of special cases as well. If you draw lines that are parallel and they don't cross, then that would be no solution. And whoops, I'm supposed to say number 3, not number 2. Infinite solutions is when there's just one line. Now, you have to check. You might have to zoom in and zoom out just to make sure it's not just off the screen. Or even better, if you just switch off one of the colors and then put it back on, you can see if it's exactly the same line. So when they're identical lines, that would be infinite solutions. So for a system of inequalities then, kind of similar to what we just did a second ago, you're going to type in the two inequalities, sorry. And this time though, you're going to look for which is the shaded area, the darkest of the shaded regions. So there's one shaded region here, one shaded region here, and you go for the one that's actually the darkest of the two. Now, if I switch it off just for a second, this is what's actually going on. We got one part of the graph here, and for the other inequality, we have another part of it. So it's actually where the two parts overlap. So if we switch them on, that's what actually gives us the darker color here. So if we're looking at points again, 1, 3, it's shaded, but it's in the wrong shaded part. So 1, 3 would be a no for this question. 3, 1 is in the darkest part. That would be good. 6, 0 is on the line of the shaded region, darkest shaded region. But remember, we don't include the dotted line. So that would be a no. And 1, negative 3, which is down here. This is on the solid line of the shaded region. As it's a solid line, we would include that answer. Now, you can have different equations, you can type them in, etc., and you will obviously be given different points as well. But basically, you're going to be using Desmos. Now, word problems. You are hungry, so you decide to go to a fast food restaurant. You have exactly $15.02, very specific. Based on past experience, you know you can only eat 7 sandwiches. Big burgers cost $3.70 and cheeseburgers cost $98. How many big burgers and how many cheeseburgers can you buy? And it's asking you to ignore sales tax for this. So I know that my big burgers, so I'm just going to call it B. I'm going to use B for burgers. Actually, I'm going to just hopefully you can remember B for burgers, and I'm going to use C for cheeseburgers as my 2 variables. It said you can only eat 7 sandwiches, so that would be at the most. So the amount of burgers plus the amount of cheeseburgers, at most, you know, you can only eat 7. You can eat 7, so I'm going to include the equal sign, but 7 or less, basically. We know the big burger costs $3.70. So $3.70 plus, not a very good plus sign there, apologies, 0.98 C. And it tells us how much money we have as well. We only have $15.02. So that's the most we can actually spend for this. 15.02. So this has to be less than or equal to $15.02. And then we can actually go across and we can actually look to see what it looks like when it's been graphed. So I typed in those 2 equations already, except I didn't put B and C because I know that won't graph. So I switched them to X and Y just to make it a little easier. So if we're looking in this region here, the darkest shaded region, these would all be valid answers here. So I could have 0 big burgers and 7 cheeseburgers. That would work. I could have 0 big burgers and 6 cheeseburgers, and etc., etc. So I can see this point here, 2, 3. That would be 2 big burgers and 3 cheeseburgers. Anything that lies on the line, I would count because we've got a solid line for this question as well. And I think we can have, yeah, we could have 3 big burgers and 4 cheeseburgers if we really wanted to. But anything in these regions up here, like 2, 6 here, that would not be a valid answer. And we're obviously going to ignore any negative answers as well. So we're really just looking in the first quadrant where we're actually graphing this. That gives us some idea of how to do some of the problems. Certainly a lot of this is using Desmos. The word problem is obviously a little bit more difficult. You've got to try and think back to exactly what they're asking you and try and match up the equation with it. That'll do it for this video right now. Go and practice the assignment for 10.2 so you can go practice those skills.